Good morning, class. So in this live lesson recording for Unit 6, Lesson 4 notes, we're going to be talking about the Pythagorean theorem, specifically Pythagorean theorem proofs. And super important to know about the Pythagorean theorem, it only applies to right triangles. So what does that mean? It only applies to a triangle that has a 90-degree angle. Okay, so you're not going to be able to use this unless it's a 90-degree angle triangle, okay, or a right triangle. Okay, so the formula itself is a squared plus b squared equals c squared. Okay, so a and b, it doesn't matter which one's a and which one's b. However, c does matter. C is always the side that is opposite of the right angle. There's a specific name for that. We call it the hypotenuse. Okay, so c is referred to as the hypotenuse. Okay, the word's right here. So hypotenuse. Okay, and we call these two sides the legs. So this is a leg. So if you see, like, it's referring to the legs, and this is also a leg. So the two other sides, again, it doesn't matter which one's A and which one's B. They're both the two legs. The third side, the side opposite the 90-degree angle, is first of all always the longest side. Okay, of the three, it's always the longest, and it's always the side opposite the 90-degree angle. Okay, so that one's important. Hypotenuse is always the side opposite the 90-degree angle. The other two don't matter. Okay, so the converse of the Pythagorean theorem says if you sum of the squares of the legs equal to the square of the hypotenuse, then the triangle is a right triangle. In other words, it's saying if this is true, then the triangle is a right triangle. Okay, so if a squared plus b squared equals c squared, then you know that you have a right triangle. Okay, so if you have like three sides, let's say, I'm just going to throw some numbers out here. Like, let's say you have a triangle that has sides length 3, 4, 5, and you want to know, is that a right triangle? Without even like doing anything else, all you have to do is plug these numbers. First of all, you know that C has to be the 5 because it's the longest side, right? The hypotenuse is always the longest side. Okay, so if these numbers work in this equation, then we know that this triangle with sides 3, 4, and 5 is a right triangle. So we could just go ahead and do that real quick. So 3 squared plus 4 squared. And we're asking ourselves, does that equal 5 squared? So that's a question mark. Okay, we don't know. Okay, and we'll go ahead and check. So that's 9 plus 16, and 5 squared is 25. Does 9 plus 16 equal 25? Yes, it does. And so this would make a right triangle. So that's what the converse of the Pythagorean theorem says. It says that if you have three sides and they fit this formula, a squared plus b squared equals c squared, then you know that the triangle has to be a right triangle. And by the way, that is definitely I knew that going into it when I picked 3, 4, 5. I knew that would be a right triangle, so that's why I picked it, in case you're wondering. Okay, so a little bit of review. This is a review from our lesson in Lesson 3. So vertical angles, I'm not going to go over every single one of these. We're not going to go over every single one like we did in the Lesson 3 recording. So there is a Lesson 3 recording where I go over all of them. But vertical angles, that would be examples like 1 and 4. So vertical angles, remember, are angles opposite of each other. So like 2 and 3 would also be vertical angles. 5 and 8 would be vertical angles. 6 and 7. So angles that are on the opposite side of an intersection are vertical angles. And one thing that we know about all vertical angles is that they are congruent, meaning they have the same measurement. So if 1 is 120 degrees, then 4 would have to be 120 degrees. Okay, corresponding angles. Those are angles that are in the same position in their intersection. So like, for instance, 2 is in the top right of this intersection right here. So we have an intersection here. That one's in the top right. And we have another intersection here, and 6 is in the top right. And so those would be corresponding angles. So 2 and 6 would be corresponding. And just as a reminder, all corresponding angles are also congruent. So 2 and 6 would have the exact same measurement. Okay, and just for some quick other examples, like 1 and 5 would be corresponding angles. 7 and 3 would be corresponding to each other. And then 8 and 4 would be corresponding to each other because they're both in the bottom right. Okay, so those are all the corresponding angles. not going to write them all down because we did that in yesterday's lesson. Alternate interior angles. So first of all, we have to talk about what are interior and exterior angles. So exterior angles are angles outside the parentheses. So these would be 1 and 2 would be exterior because these are inside the parentheses. So these would be interior. Or sorry, inside the parallel lines. I said parentheses. Inside the parallel lines. And then 7 and 8 would also be exterior because they're outside the parallel lines as well. Okay, so exterior, exterior, interior, inside the parallel lines. Okay, so alternate interior angles means they're on opposite sides of the transversal. So this is the transversal that this is like a line that cuts through these parallel lines. Okay, so alternate means they're on opposite sides. So 3 and 6 would be alternate interior angles. The other examples would be 4 and 5, but we're just going to do 3 and 6 for now. I'm only going to write down 3 and 6, but also know that 4 and 5 are also alternate interior angles. Okay, and again, alternate interior angles are congruent. So if 3 is, let's say, 60 degrees, then 6 would also have to be 60 degrees. Okay, and then for alternate exterior angles, same thing, except now we're dealing with exterior angles. So like, for example, 2 and 7 would be alternate exterior angles. Because they are exterior angles that are on opposite sides of the transversal. So this is on the right side of the transversal, this is on the left side. They're both exterior angles, so those would be alternate exterior angles. 1 and 8 would be the other example. And again, just like with the previous one, they are congruent. Okay, so now let's go ahead and jump to questions for lesson 4. All right, so this one says, does the Pythagorean theorem apply to this triangle? How do you know? All right, so first of all, this is a 30, 60, and we have to figure out what this other angle is in order to know if the Pythagorean theorem applies. Okay, so 30, 60, and if you think about the formula that tells us that every triangle adds up, the triangle sum theorem tells us that the 3 angles in a triangle have to add up to 180. So if I subtract the 2 angles I already know, I can figure out what the missing angle is. And that missing angle has to be 90 degrees because 180 minus 60 minus 30 is 90 degrees. Therefore, the answer is yes, it does. And we know it because it's a 90 degree, it's a right triangle or a 90 degree angle. A triangle that has a 90 degree angle. All right, use the converse of Pythagorean theorem to explain whether a triangle with sides 10, 12, and 16 is a right triangle. Okay, so again, basically what this means is it has to be able to fit into this formula. A squared plus b squared equals c squared. And we know that 16 has to be c. Again, a and b don't matter. Doesn't matter the order. Okay, and so again, this is a question mark. Does that equal 16 squared? Okay, so 10 squared is 100, plus 12 squared is 144. So together that equals 244. And does that equal 16 squared? Let's see, 16 squared is, I don't think that does. Pretty sure it doesn't, actually. 16 squared, you guys probably can't see that very well. 16 squared is 256. So it's close, but not quite. So that does not equal. So therefore, we would say no, it's not a right triangle. That does not make a right triangle. Now, can you have a triangle that has sides 10, 12, and 16? Yes, you can, but it's just not a right triangle. All right, let's go ahead and try the next one. 12, 16, and 20. Which is the length? Okay, so first of all, the length of the hypotenuse. Oh, okay. This one's not asking us, does it make a right triangle? It's just saying which one's the length of the hypotenuse. So the longest side always has to be the hypotenuse, so it'd have to be 20. So that's your answer, 20. All right, what is the length of the hypotenuse in this triangle? Okay, so now we can use the Pythagorean theorem to figure that out. Okay, so we know the legs. This one has to be the hypotenuse because it's the side opposite of the right angle. Okay, so we'll go ahead and plug in. Again, doesn't matter which one's A, which one's B. So we're going to do 9 squared plus 12 squared equals c squared. Okay, because we don't know what c is yet. Okay, so that's what we're trying to figure out in this one. 81 plus 144 equals c squared. And then add those two together, we get 225 equals c squared. And then our last step, anytime we're trying to solve for the final side, is we have to take the square root. Because if you take the square root of a number that's squared, we just get that number. So c would have to be 15. So that's always going to be the last step whenever you're trying to solve a Pythagorean theorem equation, is you take the square root of both sides to get the letter c by itself instead of c squared. Sometimes you'll have to get a by itself, like in this case, number 5, we'll have to get b by itself. Okay. This one says, if 18 squared plus b squared equals 30 squared is found to be true, what do we know about the triangle? Well, if that's true, then that means it fits the Pythagorean theorem, which means it is a right triangle. All right, and we're going to be working basically, so if we look through the notes for the next ones, in lesson 5, we're going to be doing the Pythagorean theorem. In lesson 6, it's called the distance and Pythagorean theorem. So we're trying to use the Pythagorean theorem to find out some distance. So again, we're using the Pythagorean theorem there. If we go to, I'm going to keep going because I just want to show you guys that basically the rest of this unit is all on the Pythagorean theorem. So if we go here, distance, the Pythagorean theorem in 3 dimensions, Pythagorean theorem portfolio. So everything for the rest of this unit is all about the Pythagorean theorem. So we're going to be doing a lot of examples of Pythagorean theorem. And we are going to be doing the portfolio. So we'll put out a recording here for the portfolio here relatively soon. But if you guys have any questions about lesson 4, feel free to reach out, book a time with me if you need help. Otherwise, have a fantastic rest of your day.